Hello, great people. We are continuing the section. Those who have not watched the previous one, please may you watch on differentiation from first principle. Sometimes they also ask a question, calculate the gradient of the tangent of the function at x is equals to 2. So when you have a question like this, what you need to do is, you see the first derivative, which is this one. You substitute x into it, and the value you get becomes the tangent, the gradient of the tangent. Alright, then let's look at the next question. They want us to determine the first derivative of this. What are we supposed to do? We are supposed to first rearrange our equation. So let's rearrange our function. If I rearrange this, you see that this x will go up to be negative 4. If you check, it's here, x to the power 4. You leave the 4 down, that's coefficient. You leave that 4 as a denominator. Don't move it with the x. We are only interested with the x. So you move the x to be a numerator. And because it was divided, when it becomes a numerator, the exponent is going to be negative. Then what are we supposed to do? We are going to differentiate. So this will multiply the value here is 1. So we are going to get 2 over 3 x. Then you are going to have 2 over 3 minus 1, which is going to give us negative 1 over 3. Then this minus 4 will also multiply 1 here. So it's going to give us negative 4 x. Then negative 4 minus 1 is also going to give us negative 5. So if we check this in actual sense, this should be like this. Let me just copy and paste what this one is supposed to be. So we are going to have something like this. Will remain as it is, but this side is going to be like this, because the negative 4 will multiply the 1, so it's going to give you negative 4. Then this side is going to be negative 4 minus 1, which is negative 5. And negative 4 divided by 4 is going to give you negative 1. So you see that you have plus times negative is going to give you minus. So this 4 will cancel each other, so you are going to have this one. Okay. Then let's look at the next question. It says, given that this is that x is greater than 0, determine the value of a if it is given that this is equal to that. What you need to do is, you first find, this one is talking about the inverse of h at 8, and this one is talking about the first derivative of h at 4. We need to equate them. So first, let's find the first derivative of h. The first derivative, this 2 will multiply a, is going to give us 2ax. Then when x is 4, you are going to have something like this. So if x is 4, this side is going to be 4, because that's what the question is demanding. Then this side will multiply 4. Then what are we going to have? This 2 will multiply for the 4, and it's going to give us 8. So this is going to give us 8a. Okay. We are done with that of the first derivative at 4. Then we need to deal with the inverse of h. And you know, to find the inverse of h, you interchange x and y. So let's call this one, if you have this one, we can interchange it and call this one x, and call this one y. So you interchange x and y, x becomes y, y becomes x. So this becomes y. Okay, then we make y the subject of the formula. So we transpose this one, a is going to divide. So if we transpose a is going to divide, so let me write it this way. I need a division. Okay, so I'm going to write my division here. Okay, I have my division nicely here. So already this x is there, so I'll have my x there. Then it's going to divide by a, so I'll have my a here equal to the same thing on that side. So this side is now, I'm going to write exactly what I have here. So here is also going to be divided by a. Then the next step is going to be like this. We will still have this one here. But this will go away. And I only need the y squared because the a will cancel each other. I only need a y squared. So this a is out. Okay, then since it's a square, you take a square root. So if I take a square root of both sides, I'm going to have this one. Because if it's a square, I take a square root at this side, I take a square root at this side. The square root will get rid of this square, and we are going to have y is equals to that. So the inverse of this h, where x is 8, you substitute 8 there, you are going to have this. Then what are we going to do? We equate the two because the inverse should be equal to the first derivative. So this inverse is equals to, our inverse is this, and our first derivative was also what? 8a. Remember, we found it here to be 8a. Alright, so since they are equal, what are we going to do? We equate these two. Then we need to get rid of the square root, so you square both sides. If you square both sides, you are going to get this one to the power that. Then you transpose this a to this side, is going to be a to the power 3. Then you transpose this 64, is going to divide, and you are going to have this. Then what are we supposed to do? We take a cube root of both sides. So a cube root of this and a cube root of that. Let me show you the cube root. I need a cube root here. Yeah, this is cube root. Okay. Where is my cursor? Okay, so here I want to take a cube root of this one. So here, this is a cube root. Then I need this one inside. we substitute this one inside. Then I'm going to have this. Also, I also need a cube root again for that one. So this cube root is going to give me that, and I only need a inside. Let me just get the cube root directly from this side. Cube root, then I need this one inside. Okay, so if I take a cube root of that, it's going to give me 1/2. Let's check on a calculator. How do we press that? Remember, we need to know how to press it as well. Né? So to press this cube root, how are we going to do that? Okay, this is a square root, shift a cube root. Alright, then we are going to press this one inside, then 1/8, the square, then it's going to give you half. You see that you've gotten your half there. Okay, see you once again. Bye.